Hello students, welcome to this video lecture. In the previous video lecture we have discussed first order linear differential equation and we have also discussed one numerical related to this. Now discussing this question number 2. The question is x minus a bracket square plus y minus b bracket square plus g square is equal to r square is given by, this is the equation, this is the form. Okay, so now solving this question, we will differentiate this partially with respect to x, with respect to y as well. Okay, so the step number 1, that is differentiating partially with respect to x. X of del by del x of x minus a bracket square plus y minus b bracket square plus z square bracket close, and this is on the right side del by del x of r square. This is equals to, so differentiating this partially with respect to x, what is the value of this one? This one will be 2x minus a, and d by dx of x minus a, that is 1, and multiplying with 1, this is 2 of x minus a. Okay, and differentiating partially with respect to x, and the function of y will be 0. Okay, so this will be 0 plus z square. Okay, so partially differentiating partially, this is equals to 2z dz by dx, this is equals to 0. Taking common from this 2, that will be x minus a plus z dz by dx can be written as p is equals to 0. This is equation number 1. Now again differentiating partially with respect to y, it will be, this is del by del y of x minus a square plus y minus b square plus g square is equals to del by del y of r square. Okay, so this will be 0 in partial differential equation with respect to y. This will be the function of x will be 0. Okay, so the function of y will be 2y minus b, and this will be 2z dz by dy is equals to 0. Okay, so this will be taking common 2 y minus v will be 2gq. Okay, 2gq is equals to 0, that implies 2 y minus b plus zq is equals to 0. So this will be equation number 2. Okay, okay, from equation 1 and 2, okay, we have a equation, we have the question, that is x minus a square plus y minus b square plus g square is equal to r square. Okay, so from equation 1 we will get, from equation 1, from this equation, listen student, from this equation we can write x minus a is equals to minus gp, right, because 2 will be 0, and from this equation we can write x y minus v is equals to minus gq. Is that correct student? From this x minus a is equals to minus gp from this statement. Okay, and this statement we will get y minus v is equals to minus gq, because 2 will be 0. So our equation will be, in the place of x minus a we will put minus z p square plus, in the place of y minus p, that is minus gq square plus g square is equals to r square. Okay, so this will be g square p square plus g square q square plus g square is equal to r square. Taking common from here, g square is a common, g square is equal to p square plus q square plus 1 is equal to r square. Okay students, so in our question we have the same, that is g square p square plus q square plus 1 is equal to r square, and here we got this g square p square plus q square plus 1 is equal to r square. Hence first order partial differential equation is verified. Answer. Okay students, the numerical we have discussed, this one question number 1 and question number 2. Okay, so this question are based on this standard equation. Okay, these are the standard equation we solved here. Okay, so now we will solve another numericals based on another standard equation. The standard equation will be, so the type 2 standard equation is type 2 standard equation. Okay, so this will be z is equals to f of xy. This is the form we will solve numerical based on this standard equation. Okay, so question number 3, we have discussed 2 questions based on the previous standard form. In the question number 3, which are on this standard form. Okay, this is a question that we are going to solve. Solution. So let u is equals to this one. Okay, z is equals to f of u is the standard form, that is z is equals to f of u. Here let u is equals to x square plus y square. Z is equals to f of u. Here in this case this is equation 1. Z is equals to f of u. Okay, differentiating equation 1 with respect to x. dz by dx is equals to d by dx of fu. This will be d by dx of fu is f dash u du by dx. Okay students, and we know that the dz by dx is equals to p. That implies p is equals to f dash u du by dx. This is del u by del x. This is equals to f dash u del by del x of u. Okay, del u by del x, that is del by del x of u. Okay, we can write here the function, the value of u, that is x square plus y square, and this will be x square plus y square. This will be f dash u, and del by del x of x square plus y square will be 2x, because the function of y will be 0. Okay, so f dash u dot into 2x. Here we know that implies p is equal to f dash u 2x. So that means from this equation f dash u will be p by 2x, and this is equation number 2. I hope you understand this expression, students. Now again differentiating Again differentiating equation 1 with respect to y. So what we get? dz by dy is equals to d by dy of f of u, that is f dash u du by dy. This is equals to f dash u, and d by dy of the value of u will be x square plus y square, and this is equals to f dash u, and with respect to y it will be, this will be 0, okay, and this of y will be 2y. Okay, so from the above equation it will be that implies q is equals to f dash u into 2y, so that means f dash u is equals to q by 2y, and this is equation number 3. Okay, so in the equation number 2 we have f dash u is equal to p by 2x, and in equation number 3 when we differentiate partially, f dash u is equals to q by 2y. Now comparing 2 and 3, we will get, we have f dash u a common, that is p by 2x is equal to f dash u is equals to q by 2y. Okay, so this will be p by 2x is equals to q by 2y. Okay students, so cross multiplying we will get, this is 2py is equal to 2qx, cancelling 2 from both sides, this will be py minus qx is equals to 0. Okay students, and this is the linear differential equation. Hence the partial differential equation is verified, and this is your answer. Now let us solve another question related to the second type of question, the second type form, that is question number 4. So this is the question: from the partial differential equation by eliminating the arbitrary function of the form family of surface z is equals to xy plus function of bracket x square plus y square. Now the solution is, let u is equal to x square plus y square, because z is a function of u, and this z is equal to xy plus f of u, and this is equation 1. Okay, z is equal to xy plus f of u, in the place of x square plus y square here I put u. So now differentiating this equation with respect to x. Differentiating this equation with respect to x, we will get x del j by del x is equals to y plus f dash u del u by del x. Okay, we will differentiating this partially, we will get y plus f dash u du by dx. Here y plus f dash u, and dy dx of, in the place of u we put this value, that is x square plus y square, x square plus y square. This will be y plus f dash u. This will be what is the value? This is 2x, okay, and this is 0, that is 2x. That implies p is equals to y plus f dash u into 2x. So from this we get p minus y is equals to 2x f dash u. This is equation number 1. Okay, this is equation number 2, guys. Again differentiating, equation 1 with respect to y. This is dg by dy is equals to x plus f dash u del u by del y. So this is going to be x plus f dash u into, in the place of d by dy of x square plus y square, this will be x plus f dash u, and this will be 0, this will be 2y, so this is 2y. This is equals to, that implies q is equals to x plus f dash u to 2y. So that implies q minus x is equals to 2y f dash u. This will be another equation. This is 3. Okay, so from equation 2 and 3, from equation 2 and 3, p minus y is equals to 2x f dash u, and q minus x is equals to 2y f dash u. Okay, so comparing this, we will get p minus y divided by 2x, comparing this, okay, is equals to q minus x divided by 2y, because cross multiply I here, 2y p minus y, okay, 2y p minus y, and 2x q minus x. This will be two y p minus y is equal to 2x q minus x. Solving this equation, this will be 2y minus p minus 2y square. This is equal to 2 qx minus 2x square. Okay, so from the equation 2y phi minus 2qx is equals to 2y square minus 2x square. Okay, so taking 2 common, this is yp minus qx is equals to 2 y square minus x square. Cancelling 2 from both sides, yp minus qx is equal to y square minus x square. And this is the standard equation, standard linear equation. Okay, standard equation, and hence solve. Okay.